All right, let's get started. So thanks for joining us today, everybody. We're going to talk about how digital drivers are changing LED lighting. Uh, LEDs are digital by nature, and so the drivers that we talk about should also be able to be digital and take care of all the opportunities that come with digitalization. So we'll get into that. So the first thing, if I can get my slides to change, sorry. The first thing that we're going to do is let everyone know that the slides and the recorded webinar will be posted. That'll be on the DLC News and Events page at our website. That should be up. The recording should be up by the end of today. Also remind you that all attendees are automatically muted as we're going through. So if you have questions, what we ask is that at the top of your screen where there is the icon with the question mark, that you post your questions in that screen, and we will answer those questions during the live Q&A. You may get some direct answers during the presentation as well. Do not use the generic chat, which is the one to the left of the question mark, as that is more informational and not the one that we're answering questions through. But if you do have it, if that's not working for you, the question mark, you can put a request in to the regular chat, just saying that you're having an issue, and Lauren will make sure that she addresses that with you. So for those that are not familiar, maybe joining us for the first time, I just want to talk about who the DLC is. The Design Lights Consortium is an independent, sorry, it went forward on me. There we go. The Design Lights Consortium is an independent nonprofit organization providing decision makers with data and resources on quality lighting, controls, and integrated building systems to reduce carbon, energy, and light pollution. So our members are utilities and utility programs throughout the US and Canada. So we cover a lot of ground. So just quick agenda of what we're doing today. That we'll go through some introductions. We'll talk about the value of digital drivers. That'll be the bulk of it. Then also show how this is going to be appearing on our qualified products list. And then also just tell everyone about our 2026 DLC Summit, which is an opportunity for everyone to join us face to face. And then we'll spend about 15 minutes going through on questions and answers. So from the presentation side today, you have myself, Stuart Brzezinski. I am the technical director here at the DLC. Joining me as a co-presenter will be Carol Jones. Carol is the North American Market Development Manager for the Dolly Alliance, and she'll talk a little bit about what they do as well. And then supporting on the Q&A will be Leora Radetsky, our Luna Program Director and Senior Lighting Scientist, and Jason Jeanette, our Technical Manager. And Jason handles a lot of our controls work that goes on. So the first thing is to really talk about how digital drivers, and what is a digital driver, I guess I should start off with. So digital drivers are enablers of much more than just analog communication, right? So your digital driver, we have digitalization in everything that we do today, if you really think about it. If it wasn't for digitalization, we would not have everything at our fingertips that we do. We ask for something, we get it. Digitalization has been in the building environment for a while. right? In the HVAC world, they went into digitalization back in the 1990s. The lighting industry started down a path of digitalization in the early 2000s, but it hasn't quite gotten there to the extent that we all would like it to. And so now you have the opportunity with LEDs, which are digital by nature, that they should be working with a digital driver. And so, in general, at a high level, a digital driver will provide the opportunity for individual addressability. So you can talk to an individual driver as opposed to a generic circuit. And then the other key thing is with digital drivers, they allow for two-way communication. So analog gives you one-way communication. You send a message, you don't, and then it just goes downstream and you hope something happens. With digital drivers, you can get feedback on there so you know that something actually did happen. So I'm going to let Carol talk a little bit here about the screen will change. Sorry. There we go. So I'll let Carol talk a little bit as well here on what her role is and the digital drivers as well. So go ahead,
Hi
Carol.
there. Sorry about some technical difficulties. I'm really glad to be here. My favorite topic. So the DALI Alliance, because not everybody knows who we are, just quickly, the DALI Alliance is a nonprofit organization, member-driven organization that that has created the internationally standardized protocol for lighting. So it's essentially the language for lighting, and it gets developed by the Alliance and then put into the global standard IEC 62386 is I think what it is. And so this communication is specific to lighting, and it's been around for a long time, highly reliable, not going anywhere, globally used. And so the protocols of communication, but there are 3 different types of DALI that you probably want to know about. One of them is wired. So DALI 2 wired systems. D4I is a luminaire level lighting control, which means that you have integral, that's where the integral sensors go for LLLC, and DALI Plus is fairly new. That is a wireless approach that is a fully native wireless approach for DALI communication. So that is the basics about who DALI is. You got the slides, Stuart?
Yeah, just a little slow moving. There we go.
There we go. So I almost had the latest slide here, but you get the idea. As I said, we've been around for a long time. It keeps growing and growing and growing, and it's growing in North America. That's very important. This has been a region that hasn't really gotten there yet, right? So 0 to 10 is the prevalent way to do lighting, but this is not a risk. It is a very high value approach, and it is the standard way to go about it in other regions. So we're very happy to be focused on North America now and getting more and more folks involved here. So we're seeing more manufacturers who haven't been here previously, who are starting to be here previously, and a lot of manufacturers that are already in the region who are expanding their product lines. So nobody likes charts or graphs or drawings like this. Some people do, right? But just to make this as simple as possible, the driver, the LED driver has integrated bus power and also the data. So you get both with DALI. And the interluminaire D4I gives you communication to the sensor device, which is integrated into the fixture. And so the power and the data are connected to the bus. So we have developed an interface, a gateway, which not a gateway in a box, but a software interface that connects to other wireless systems. So that allows us to communicate to Bluetooth NLC and some Zigbee protocols devices. So what that means is you get both the DALI driver, and you can then communicate with an extra another wireless layer, which is not DALI, but it allows you to connect to other systems. We have partnerships in the other partnership is Zaga Consortium. I don't want to forget, it's on the slide for a reason. Zaga Consortium is actually an organization not unlike DALI, but the focus is on mechanical interfaces. So what that means is Zaga Book 20 will give you a mechanical device that allows you to put your sensor into the fixture and then replace it with the same form factor at a later time.
All right, thanks, Carol. And the one key thing that I'll add to what Carol just said is that D4I is a major enabler for LLLC luminaires, luminaire level lighting control luminaires, let it be indoor or outdoor. So one of the first things that we want to talk about is around accurate energy. So when you look at, let it be a utility program, a building manager, facility manager, whoever it may be, it's really important that the energy savings that is planned is being met. From utilities, it's important on the evaluation of their programs. For facility managers, it comes down to their operation budgets as they're trying to maintain and meet those budgets. But what happens when the fixtures that are being installed today, which many of those are dimmable, what happens when dimming is happening? Are you meeting that predicted energy savings? That's one of the key things, right? So we've got 0 to 10 volt systems today, and then we've got dolly systems or digital systems that we're talking about as well. So this is where this is where it becomes really important to understand what the differences are in the different technologies, right? So you have reliable and accurate data, and the reporting becomes really important. And then the other thing I'll just mention is ANSI, American National Standards, that they've developed what's called C137.9, which are configuration reports for standardized configuration report for use by NLC manufacturers, lighting control manufacturers. So a lighting control manufacturer can institute the use of the C137.9 standard report. And so after an installation is done, it can generate that system can generate some standard configuration reports that you then have as a utility, as an end user, that can say, here's how my system has been configured, and understand what that savings should be, right? It takes you one step further than just the commissioning was completed, but here's a report that helps you being able to see that. So I'm going to let Carol talk a little bit more about how these energy savings can be met.
So this is a part 252. I'm going to talk for a minute about how you get this accuracy and the energy savings. So when DALI develops all these different specifications, and just for clarity, we call them parts. So when you see part 252, it's actually a specification with extremely detailed information about how to build DALI devices. So that one of these is energy, and this box over here just gives you an idea all the different types of information that you can get from the DALI drivers. So it's very precise, it's very comprehensive, and what that allows you to do is to be really accurate with your savings. I remember quite a while back when there was a lot of conversation about with 0 to 10 drivers, what should the band be around it that was allowed, if you will, in terms of accuracy. And there were conversations about 5% and 2% and that kind of thing, like how much variability can there be? Well, in fact, there's a tremendous amount of variability. The 0 to 10 drivers do not give you accurate information. And so I can't remember if that slide is in here, Stuart. I don't think so, right? There's a
No.
Yeah, there is a picture so PNNL did a research study not very long ago, Pacific Northwest National Laboratory, looking specifically at how analog drivers, 0 to 10 volt drivers, behave one to the other for each of themselves and also compared to each other. And they found that there was a tremendous amount of variety, sometimes up to 50%. And so the problem with that is that energy programs, utility programs, anyone who's concerned about it, they need accuracy. They're buying a product in order to make sure that you're saving energy, and they don't know what that answer is. So the information that has been used for a long time is not something that it's not really good enough in today's day and age, because the energy savings has already come down so much that you need to be much more precise about that. So this gives you all that information, and that allows you to then not only connect with the lighting energy savings, but also other systems, and be able to get down even lower than you can with LEDs. So this is a picture. I was just talking about a picture from Pacific Northwest National Laboratory. It was part of a street lighting report that they did. And if you can imagine the same curve, there were lots of different color lines, and they were very many different shapes. So what I'm showing here is a contrast to that, where you have digital information. So when you're using DALI, you know exactly what this curve is going to look like. So to the eye, it looks natural. It looks natural to the eye. It doesn't look like the curve shows it. Based on our physiology, it looks like a regular linear dimming curve. And so that's wonderful. That means that the customers can use the dimmer or have settings or whatever else, and it's going to be 50% of the light and 50% of the energy, and you can know that reliably. With a 0 to 10 volt dimming system, you'll probably recognize this. When you're dimming at the wall, there's nothing, and then all of a sudden in the last 20%, you're trying to dim 100%. So this just makes it reliable and consistent.
And as you mentioned earlier, Carol, Dolly is a standard. So any driver that is a Dolly driver will be this specific curve. It won't be the different random type, I shouldn't say random curves, but the variability in the analog 0 to 10 volt curves.
Right. And you do have the power to change the curve if you want to. So it's highly configurable. Everything in the Dolly devices are highly configurable. It's important to mention very specifically that DALI requires certification. For anybody who's old enough to remember when DALI first came to this market in North America, there was no certification at the time. The specifications were done, the protocol was developed, but there wasn't a testing process. And so once that got introduced, which it happened, I think it's 2017, but it's the kind of thing, it just was a pivotal difference. So there's before and there's after, and it's the after that we want people to be aware of. They're not necessarily aware of it, but that testing gives you trust that you're able to have a true DALI product, and also that they are interoperable, which I'll talk a little bit more about later.
Great, thanks. So one of the key things also is around what is going on in facilities, right? And when you start talking about what's going on in a facility, everybody wants to have the initial costs and maintain costs. Those are things that you're really thinking about, right? How are they fitting in on the budget? How are they aligning with rebates? How are these systems getting installed in such a way that you can implement a digital system cost effectively? Because many times people are thinking about it's dimming, it's going to cost me a lot. It's how do I get this installed? And you really need to be looking at things not on just the initial, maintain cost as well. So as an example, if you have a large office area, and let's just say every couple years or so, whatever, it's getting reconfigured. People are moving to different spaces, walls are going up, things like that. the use of digital drivers, addressable drivers, as we were talking about before, that you don't have to go and move light fixtures around or recircuit things. The digitalization of the drivers allow you to tell that driver, okay, you're going to change and you're going to be in a different group now, or something like that. So it makes that operational cost a lot easier. And then also, because of the ability of the two-way communication I talked about, you can get data back from drivers, and some of that data can tell you if there's a failure of a driver, or a pending failure as well, depending upon how things are set up. So there are a lot of things on the initial cost that Carol talked to on. It doesn't cost more to wire these up initially, install them, and then also the opportunities around the maintain costs also are really important. Carol, I don't see another slide. Do you want to, for yours, do you want to talk to us a little
Yeah,
bit more?
yeah. So there are some mythologies about DALI, and one of them is that it's very complicated. And it used to be that flexible sort of equaled complicated, right? In before we had digital systems. Now, having a lot of features and having things that could be considered complicated, it's really not that way, because the interfaces figure all that out for you, so that it's not just because it's powerful and advanced, it does not mean that it's going to be difficult. I'll give you an example. When you're installing DALI, you don't have to worry about the directionality of the wires. You don't have to worry about polarity. It is actually a very simple installation, and more cost effective. What I find is that people say to me once they've done it, "Gee, this is so much easier than I thought. I really thought this was going to be hard." And it's hard to convince people of that until you try it. But chances are you're familiar with this in any case, because there have been some DALI-like systems here, but it's easier. And in terms of the ongoing maintained cost, we're post-COVID now, so it actually happens far more frequently that people are changing spaces. Hybrid workers, things are getting modernized to allow for that flexibility. And part of that flexibility is that you need to change your lighting sometimes, whether it be from churn, or changing it to a different use case, or there's all sorts of reasons that changes are happening now. So that you've got that opportunity. The fixtures, we have addressability a little later. I'll save that a little bit later. You- I was going to talk about how the fixtures can all be handled separately, and I'll just say it now just in case. The communication to the fixtures is, different signals can be sent. First of all, it's not just dimming, right? It's analog is by design, it dims, but you can't communicate. And you can have at the same time with the DELI system, you can have a perimeter daylight zone, which is required by code most of the time, and you can tell that group to handle daylighting dim as necessary. But you also can have a different group for a different purpose that includes some of those daylighting fixtures. So it's not like you've got a circuit and then you're dealing with the fixtures that are on that circuit, and that's all you can do. You can map to the different fixtures and drivers and tell them what to do without changing the wiring. So there's tremendous flexibility. That helps a lot during the operational phase.
Thanks, Carol. One of the big opportunities for to maximize the energy savings, I'll say, in a building is the integration of HVAC and NLC systems. So there are studies that have been shown, or that have been conducted, and some of those done by the DLC as well, that show that you can achieve anywhere from 20 to 30% additional savings in a building by integrating the NLC and HVAC systems together. So if you're a utility, an efficiency program that is still having to meet energy efficiency goals, savings goals, and you may be in an area where you're saturated on your LEDs, or maybe you're not offering rebates on the LEDs, LED retrofits by themselves. Looking at ways to integrate the NLC and HVAC systems together can help to achieve your energy savings. And then if you're a facility manager, let's say, or even an ESCO, this is an opportunity to really dig in and get more energy savings around your building as well. So there are things that you can still do when you start thinking about putting your systems together and having them work interactively that become really important. Now, one of the barriers that the DLC identified through some working groups that we've done is that the mechanical people and the electrical people aren't talking to one another because they don't understand one another all the time. The lighting people don't understand what's going on the mechanical side not understanding the lighting side, just as one example. Or people don't know how to determine if their project is a good fit for an integration. So the DLC has a integration toolkit available, and you can get it off from the QR code or going to our website with the link below. And this is a free integration toolkit that you can download that has some of the things I talked about and a couple of other items, which will help you to determine, is it a good project? How do I talk the language of the other, right? How does the lighting person talk to the HVAC and back and forth? So there's a lot of different things that can be done to get to NLC and HVAC integration. Carol, you want to talk a little bit more about how that can happen in a digital world?
Yes, it used to be that lighting was the thing that was the low-hanging fruit, and the energy use in a building was very high. It was 30-ish%, something like that. And that changed with the introduction of LEDs. And so that's wonderful that so much lighting energy has been saved and is contributing in that way. And it's a different sort of world right now. The biggest energy user in buildings is the HVAC system. What we're trying to explain to people is that, raise awareness and such, educate. So this is a great toolkit from DLC, really very helpful. The education is important because the ability to connect the lighting to the HVAC, we can leverage additional savings in ways that people wouldn't have necessarily thought of. So when you map the sensors from the LLLC systems, where you've got integral sensors and you've got a D4I driver, when you map those to a zone, an HVAC zone, you can use the occupancy data to be able to have HVAC setbacks, temperature setbacks. So that, even small setbacks cumulatively can save a lot of energy. And that's a great opportunity. I think people are just starting to wake up to that, but I anticipate that there will be a lot more of that. It's not the only system, by the way, that you can integrate with in terms of using Dali products. They are, it isn't a complete system. It's not just the driver. So the switches and the sensors and et cetera, the certifications apply to the whole system. So what that means is you can have a driver from one manufacturer and switches or sensors from another manufacturer. If you need to replace it, then you can do that through with somebody else's product if you can't get what you need to get your hands on fast enough. So all of these things make it easier to connect to the building. We have two-way communication. We can connect to the other digital systems and talk to each other and say, hey, how can I help you? So that's different. And there are a lot of opportunities out there. So HVAC and more.
Yeah, and in large buildings, you tend to do this with BACnet, and the integration wasn't happening as much in the small to medium-sized buildings. Just mentioning how that's starting to happen more now because of thermostats.
Yeah, we should mention that Chris Walgamot at the Northeast Energy Efficiency Partnerships has been doing some research on this. So some of the numbers that Stuart was talking about have actually been measured by an independent party, and that's it's great. It's an important thing to be aware of, but I just want to give due credit there because it's an intense piece of work. And from that, we're going to benefit, and there'll be more and more information about both types of HVAC integration.
So another real important area is about the sustained operation, right? So from utilities, you are making an investment in incentives to have the lighting installed because there's the savings that you're going to see that's going to impact you and the electricity generation distribution. And then facility managers, you're making an investment and you want that investment to provide the returns. So making sure that system is going to be operational over time, that if at any point there is a failure of the driver, that when that new driver is installed, it's going to fit right into the system and work accordingly. So there's a lot of things by utilizing standards. So standards like Dolly, also DMX, which I forgot to mention earlier.
Yeah.
Dolly and DMX are kind of the two digital standards that exist here in the US. DMX being coming out of the theatrical world, but showing up more into the architectural world now. Primarily when used for color. So let it be like RGB color mixing, things like that. DMX is also really fast. So you may find it a lot on outdoor installations where you have color changing on bridges, buildings, things like that. So there's a lot of different things. So when you're utilizing standards, it helps when you have to have sustained operations as well. So, especially when we're doing LED to LED retrofits now. So now's the time to really think about what you're going to put into a fixture, and whatever you put in, make sure that it's controllable, right? Because it's going to be 10 years until you're replacing that fixture again or so. So you want to get LED to LEDs are good, still legacy to LED, but make sure controls are going in there as well, because it allows you to have that sustained operation long term as you're going through. Anything to add there, Carol?
The operations phase is something that people who work in buildings don't necessarily think of. Facility managers, yes, anybody that is in the building, staying with the building after it's turned over, after the retrofit or the project is done. But it's extremely important. The people who own, manage, lease tenants that are in the building, it becomes very important. And we tend to, as an industry or community, we're more focused on other things that are associated with when we engage with the properties. But the customers really need it to go well over time. So they need this information. The fault diagnostics is one of the things I want to make sure to mention. Dali has the ability to report on faults if there's a lighting fault. That's something that's well appreciated by the customers in the operations phase. It's mostly been HVAC, so people know what a fault is, and there's a fault, and there's information about what has gone wrong, and then that's communicated digitally. So that happens with Dali, and so it's not just about, oh, okay, something's wrong, pay attention to this fixture. It says there's a problem and here's what it is. So once you know, it's giving you diagnostics information in addition to identifying where the errors are. So you only need one truck roll. I think we should in general pay more attention to what folks need in the operations phase.
Yeah, thanks, Carol. We're going to talk about addressability and what that provides, because again, with the digital nature, drivers are addressable. So one of the key things to think about, we're all hearing about this, right? Electricity demand is increasing. Let it be due to data centers, right? We're all on the internet all the time. Many of us are using AI, let it be Claude, Chat GPT, whatever it may be. As we're moving, all of the information we want, all the things that we are doing increase the demand for electricity. Electric vehicles, data centers, I'm sure you can think of a lot of different things that are going on. And so we really need to be cognizant of how we are going to manage our electricity, right? So you can do demand response, right? So where the utilities are saying, hey, we need you to cut load because too much demand on the grid right now. You could also be looking at it from your own building where you want to flatten out your load better. So when you have the digital nature of addressability, that you can manage that loading much better when you can get down to the individual fixtures. And I'm going to let Carol talk a little bit more about what some of those things are that help this out.
Yeah, so the addressability is you can be very precise, and the more energy we need to save, the more precise you want to be. Example, demand response. The real-time automated demand response approaches are important because in dealing with the grid and trying to smooth that out and manage all the changes that are happening now, especially with electrification, being able to communicate with each fixture also allows you to level it out, not just with the energy, but with what's happening inside of the building. So what I mean is that if you're in a workstation area, you can't you can't dim quite as much as you can in some other areas. If it's a transition area or a cafe or some other area, you can dim in a more significant way than if you are in a workstation area where people need to see. The addressability allows you to save as much energy as you can possibly save without compromising what's going on in the building. And there are so many examples of how that individual fixture saves you from what would otherwise be happening. The comparison to the circuit level and the individual fixtures is very significant.
Great. Thank you, Carol. I'll let you talk a little bit around the interoperability and fault detection. I know you talked a little bit about that, but I'll let you do just a little bit more. I think you wanted to expand on
Sure. And we're gonna be shifting over to you shortly, so we need to try and
that.
make sure we cover things. The
Yep.
So I did talk about the interoperability earlier. I talked about fault detection and diagnostics earlier. So that's the only things that have occurred to me since I mentioned that are that I mentioned that there's certification, but it's also important to let you know, how do you find out if DALI is actually certified? There's a database that you can get to. If you go to the DALI website, you'll be able to go to the database. And I strongly encourage anyone who's using DALI equipment to go and make sure that it's in the certified database. That's really important. We don't want anybody being disappointed. So that's why we do the testing. I just forgot that earlier, but I don't want to miss it. Um, Color is also another thing that I don't have a specific slide for that, but keep in mind DT8. DT8 is the driver that gives you digital control of the color. And you can do your warm to cool in a way so that the fixtures match each other no matter what the types are. So you have different types of fixtures from different manufacturers, and the management of that, if it's digital, if it's a DALI driver, DT8 is the simple way to put it, that will be consistent. This slide here, I mentioned that we have interface, a software gateway to other types of systems. D4I is here. The controls software is up above that. Just think in layers. Control software that manages the dimming and the changes in the data. And there's the driver, the equipment. The interface allows you to get to a wireless network that belongs to others. So Bluetooth NLC is one example. Zigbee is another example. We worked with those partners to make sure that there's a way to connect these good systems together on behalf of the customer. So that means that if whatever happens with your system, if you have interoperable devices, and you have interoperable mechanical, and these are qualified and certified, this gives you the kind of a kumbaya holy grail that people have been talking about for a very, very long time. The issue is that people don't know enough about it. They're not even aware. So that's good news.
Yeah, thanks, Carol. So I know Carol and I have covered a lot of different things, 5 different areas that we were focusing. But, we know that this is something new to a lot of people, and it's not going to be something that you're going to be able to absorb just in this little bit of time. So if you have additional questions or things that you want to talk about, feel free to reach out to the DLC, myself, Carol at the Dolly Alliance as well. But one of the things that we are going to be doing is on our qualified products list, we are going to be identifying digital products, what as we call them, badges. These will be on our product listing page. So when you go into our qualified products list and you search for a product, and however you get there, and this is the page that would come up, you would be able to see that this product, the one I have highlighted here, that this product supports D4I. There would be a badge for Dolly 2. There would also be a badge to support DMX 512. So it'll be a quick way as a user of our QPL that you can see which of the fixtures shown support one of the digital protocols. And there are some other digital protocols that may emerge in the future. So we would also make sure that we can support that as well. So once you click on this, it would take you to our product detail page. And again, on that product detail page, you see in the top right the identification of that badge as well. I think some of our slides might be out of order, doubled up, Carol, so I'm just going to jump. So the next thing that I just wanted to let everybody know is that the DLC will be holding a summit October 26th to the 27th in Los Angeles. And that summit is sponsored by our host, the Los Angeles Department of Water and Power. The summit will be in downtown Los Angeles at the California Endowment Center, a really nice building. We have a room block at the DoubleTree in Los Angeles. So if you go up on our website, you can register for the summit. We have a lot of, we have some of the agenda items up there, abstracts, the reasons to attend. It's a day and a half. On day one, for industry partners, we'll be spending a little bit of time going around challenges and things that are going on in the industry, and also preparing you for day two. There will be a member meeting concurrent with this, so any of our members that attend will have their own meeting. On day one, we'll also do a tour of the La Cretz Innovation Campus, and that'll be a great time for networking also. And then on the second day, we've got an agenda which you'll be able to get more detail on our website. But it's going to focus around advanced controls, around the integration that we talked about today, and then also what savings look like in the future. And then we're also going to be talking about light pollution and controllability of lights and how those all play together, the impact that they all have. And then in the afternoon, we'll have a breakout working session in small groups that we can look at identifying the market realities and new opportunities. And then lastly, for the summit, we do have sponsorship opportunities. So if anyone's interested in sponsoring, you can go up on our website and find that. In the meantime, why don't we go to the Q&A, because I don't want to run out of time on that. So Leora and Jason, who are managing the Q&A, where are we with questions that we may want to address here?
We have 4. And why don't I just ask them to you in order that they came in? So the first one, I think, is for Carol. And the question is, for Dolly drivers, is there any reason why a manufacturer developing a new Dolly driver would launch Dolly 2 and not D4i?
Well, it's a good question. So DALI 2 is technically everything that is after the beginning of the certification. So so that's DALI 2 marks the beginning of the testing program. So D4I is also DALI 2, but it's not. We need to distinguish between them because they have different different features and capabilities, different architectures. So DALI 2 DALI 2 with wired system is one way of using DALI, and D4I with a wireless layer is another way. DALI Plus is DALI equipment with its own wireless. So for anything that is using DALI 2 wired, D4i, DALI Plus, any of those, they are all DALI. They all can communicate with each other. They're all backwards compatible in terms of the data and how that's all put together. So I hope that answers your question in terms of which one do you use. It depends on the system and the project.
Yeah, if I can add, Carol, the typical installation where you're seeing D4i today is like the diagram you had at the very beginning. That
Yeah.
D4i you're finding inside of a Luminaire, where you have the sensor and the driver all communicating within that small, I'll say, the package of the Luminaire. Where DALI 2, you may not have all the integrated sensors. You're on the full wired system as you're going through. So it depends on it from a manufacturer also as to which route you're going, what you're trying to develop, what you're trying to provide for the end users. I think also helps to dictate that by looking at what the feature sets of the two are.
Yeah. Another thought that just came up from what you said, Stuart, is from the drivers are all DALI 2 drivers, and there's not much different between D4i and DALI 2. It will depend on things like, are you going to have color? Do you want emergency? Or do you want it to be intraluminaire? When you are using wired systems versus planning to use it with a wireless layer, you have to do slightly different configurations in the factory. But it's not really different. It's just more about how you're applying it, whether it's inside of a luminaire or whether it's part of a more connected system with wires. If the power situation is different, for instance, when you're providing power to each of them, that's slightly different. But it's all DALI 2.
Okay. We'll let that person follow up if that isn't answered, but I
Yes.
think that was a very
It's not
complete
necessarily
answer.
the easiest. Yeah, it's not necessarily the easiest thing if you're not familiar with the system to know the differences between them. So I absolutely encourage anyone who's listening today to reach out and get any kind of clarification. We have some new materials on our website, and one of them is a book that has a lot of really good information in it, easy to read, lots of pictures. So it will help. Go to your computer and download that publication, and it will answer so many questions. And whatever you don't learn there, get in touch with me.
Great. Okay, this next question is a two-parter. I think perhaps you both can answer the first part of the question. I think the second part of the question specifically is going to be better answered by you, Carol, but feel free to both jump in, of course. So the first part of the question is, in what scenarios is fixture level addressability necessary rather than optional? And then the follow-up is, can 64 limitation of DALI support LLLC in large scale applications? So hopefully that's clear.
Okay. So I'm going to need a reminder part way, but the one that you
That's
just
fine.
read about the
64
about the
limitation.
yeah. So it's not a limitation. It's just about the way that the system goes together. There have been DALI systems installed that are huge, massive infrastructure projects. Um, so yes, there is a subnet, but in terms of the size of the project, it's not a limitation in any way whatsoever. It's 80,000 drivers. I just heard about a new project that was just done, and these are big projects that are happening all over the world. So scalability is not an issue. The way that it's done is slightly different. So when you're if you are not using the wires for all of it, if you're using a wireless layer as well, it's true that you don't have a subnet per se, but you still need to deal with groups and such. So it's not really as different as you might think. Certainly when
Okay.
going to scale. What was the first part of it? I missed
So the first
part.
part is, in what scenarios is fixture level addressability necessary rather than optional? I think both of you might want to answer this.
Yeah, so it sort of a straight up answer is that it depends on what you want out of your lighting system. If you want accurate energy reporting, then you're not going to get it from 0 to 10. Full stop. You just won't. If you want linear dimming, you won't get it from 0 to 10. If you want information beyond the circuit-based measurements, which sometimes includes other load or from the building, you're not going to get accuracy as well. And if you want to have connection to other building systems, that's necessary to have. It can be anything from an occupancy technology that is a platform in and of itself. So all of the features that are discussed here, it depends on if your project wants to have those features. If you want to have color tuning that's consistent, so you don't see yellow and green all over the place, DT8 is the way to go. If you are interested in having lighting, so AI, do you want AI or not? Do you want the data from your lighting system to be usable in AI applications with the rest of the integration of the building, because that is happening. It's happening fast. Lighting is either in the room or not in the room. It's either an opportunity or it's not an opportunity. If you go with analog 0 to 10, it's not an opportunity. There's no discussion, there's no communication, so it's just off the table. So, in my view, going forward, this is the time where digital really, really matters, because any of those folks that are putting together AI systems to maximize all of the different relationships in the building, yeah, that would be a useful thing to have. Stuart, you were gonna.
No, I want to make sure we get to some more questions. I agree with everything that you said there. So.
Okay. All right. Next one is okay. There's a lot that have come in. Okay, so this one again was about maximum addressable with a single DALI line, 64 or 128, option to increase. So I think this one might be a little bit in the weeds, and perhaps we answer this one.
I think I know what I may know
Okay.
what is being asked here. So a subnet can have 64 control gear like drivers, but also 64 devices. So think of it like 64 drivers and then that same number of switches or sensors. So that's can you expand beyond 64 and 64, meaning for the driver and peripherals? No, you can, but you do join them all up from one gateway to the next, and your control system is able to operate the system in its entirety without any trouble. But yes, you do, when you're using DALI 2 wired, there is a wiring system where you need to have a subnet. If you compare that to, I always found this interesting. People think about that as a limitation. How does that compare to electrical wiring, circuit-based wiring that goes all the way back? The amount of wire and copper that's used in addition to the electrical engineering, DALI is far simpler. So yes, that's a number, and it does matter, but it's not as big of a limitation as most people think.
Okay.
I hope that helped. I hope that was a decent answer. If not, yeah.
We're having some, when you look inside, we're having some community answers, which is good. Okay, so Stuart, this one is for you. Will the new D4I badges also be applied to the NLC QPL? and include NLC systems that offer DALL-E 2?
Yeah, so the badges on the NLC, I'm trying to think, Jason, as I know we've talked about that. Right now, we've been focusing on moving from the SSL to the NLC to identify that.
The short answer is we haven't actually designed the new QPL yet, but
Yeah.
we can certainly include those.
Right.
Okay, we've got some live decision making happening. Terrific.
That was the answer. Yep.
Okay.
Thanks.
Thank you. All right, so here is another one. I think this one is for Carol as well. I am trying to be fair in assigning these, though, I promise. When it comes to DALL-E compatibility, is there a list out there of DALL-E compatible emergency battery backup drivers that can report back status on a DALL-E bus? Most of what we have found is European market specific.
So most of it is European, yes. It is a tremendous feature because you can get all the information digitally. It allows you, when you're connecting to emergency with a DALL-E system, it allows you to do the remote testing so that you don't need to get up on a ladder, and you get all the information that you need there. So as far as I know, there's not much here in terms of what's available in the market yet. I mentioned before that the supply chain is getting better, so that is one of those things that we do expect to see, but it's not prevalent yet, and I don't remember how much product there is, but you can tell by going to our database.
Okay, I
Hey,
think we
Leora.
maybe have time for one more, and then I think we're right at 3 o'clock. What do you think?
Yeah.
Or should we just wait and answer
We can
these
go-
one-on-one?
We can go one more. It's a
Okay,
short one.
let's do one more. Let me find. Okay, this is the last one. Can you explain the difference between a Zaga Book 18 receptacle as a D4I self-certification versus Zaga D4I official certification with additional third-party validation?
Yeah, so there is a certification program that includes both, meaning that the testing is done for both Zaga Book 20 and Zaga Book 18, so that it's actually a combined system. So you have certification for both, which means that you have the interoperable features reliably, and you also have the interoperable mechanical. So I think that was the main thing. I think I'm hearing what are the differences, and it's not really a difference. It's doing them together instead of a la carte, I guess, is one way to think about it.
Okay,
Book 18 is exterior, in case anybody didn't know that. Book 20 is the mechanical devices with exact measurements and the leads and everything else is described specifically. Book 20 has the one for interior. Book 18 has the one for exterior. There's been a tremendous amount of activity in the exterior activity with DALL-E in this region, because the poles are so far apart anyway that it just makes a lot of sense, and it's very good economically.
All right. Well, thanks, Carol. Thanks, Leora and Jason on the question side. For those that submitted questions that we did not get to, we will answer those and get back to you with feedback on those as well. But I want to thank everybody for joining us today. And again, if you have any further questions that come up, feel free to reach out to Carol at the DALL-E Alliance or myself at DLC. So thanks, everybody, and look forward to seeing you, hearing from you in the future. Take care. Bye.
Thank you so much.